I'm John Johnson, Automotive Systems Marketing at ST Microelectronics. Today we're going to have a brief discussion about lithium-ion battery management in electric vehicles and other battery-operated applications. We'll explore how ST's battery management solutions help cars travel further and batteries to charge faster and last longer. So hop in and let's go. In electric vehicles, the battery management unit is part of a system that stores and converts energy into motion and vice versa. Electrification will have a profound impact on the vehicle electrical system going forward, as many systems traditionally based on hydraulics are now driven by electric motors. In the world of battery-operated products, and especially electric vehicles, battery management is perhaps the most important aspect of the product. Why is this? An article published in the Wall Street Journal in 2019 provides some insight. It identifies the battery as, quote, the big obstacle on the road to electric vehicles. The battery system is the most expensive component comprising the bill of materials. For this reason, batteries must be able to impact performance and functionality in a big way, commensurate with its relative cost. So the care and feeding of the battery pack is a big focus to ensure that it delivers the performance and longevity that justifies its cost. Several factors go into the design of a battery pack as well as the battery management unit. Ideally, battery packs should outlast the service life of the vehicle itself, and it must do so in a safe and efficient manner. Accomplishing this means monitoring and controlling certain operational parameters. Now let's look at some of the nuances of battery management in an electric vehicle. Battery management implemented in electric vehicles is quite different than something like a mobile phone. A mobile phone battery system is optimized for two primary factors, that is cost and talk time. Longevity of the battery is not a concern as mobile phones are typically upgraded every 2 years. By contrast, the electric vehicle battery pack should ideally last for the service life of the vehicle. To do this, the pack is typically sized for a larger capacity than the desired target range based on the efficiency of the vehicle platform. So, the BMS in a new vehicle charges and discharges the pack to something significantly less than full capacity. As a vehicle battery pack ages, the capacity is diminished and the BMS charges and discharges the pack over a broader range. Thus, overall, the perceived vehicle performance is retained over a longer period of time despite the fact that the capacity of the battery pack is diminished. The chart above lists a few of the methods of gauging battery capacity and performance as well as some pros and cons of each approach. Intuitively, monitoring cell voltage to track charge and discharge and hence capacity seems like the simplest approach to implement. However, there are potential pitfalls. First, mid-charge lithium-ion discharge curves are relatively flat as shown. This necessitates the use of a very high-resolution signal path. In addition, cell voltage is impacted by load current as well as temperature variation, further complicating the issue. Most academic papers that address fuel gauging in a lithium cell suggest that the battery be unloaded for a long period of time before cell voltages are sampled. Obviously, some aspects of cell voltage monitoring are impractical for EV applications. Hydrometers are employed for chemistries like lead acid in which there is a fluid that can be evaluated. For example, for lead acid chemistries, sulfuric acid density increases as lead acid battery charges, which can be measured with a hydrometer via specific gravity. Obviously, if the fluid level changes, the ability to accurately estimate state of charge can also be affected. Coulomb counting is an effective means of fuel gauging, but it is not without its drawbacks. It entails keeping a rolling tally of amp seconds in and out of the battery pack. However, no battery chemistry is 100% efficient in terms of charge and discharge. That is, current over time does not equal current over time out. As we discussed earlier, the objective is to ensure that the charging and discharging of the battery is carefully managed. This is not only to manage vehicle range via efficiency optimization, but also to maximize battery longevity. If an entire battery is charged to 50%, yet a single cell is already at 80%, the result of charging the entire battery to 80% will result in cell damage for that single cell. Or one or two cells may be at a lower level of charge than the balance of the battery. If the battery is discharged at 30%, then perhaps these cells are fully discharged in the process. So the battlefield not only takes place over the entire battery, but also each individual cell. The charge on brand new cells is not exactly the same either, although offering quote-unquote match cells is sometimes marketed by the cell manufacturers. Cell balancing or equalization provides a mechanism to level all the cells to nearly identical levels of charge, thereby maximizing battery longevity as well as vehicle efficiency. As the chart shows, without proper cell balancing, the longevity of the battery is impossible to maintain over a large number of charge-discharge cycles. Let's take a quick look at a BMU chipset offered by ST Microelectronics. This solution comprises power management and microcontroller components that can be found in many automotive systems, but the chipset also includes devices that help keep the battery performing well in areas like safety, efficiency, that's range per charge, and longevity, make the battery last a long time. The centerpiece of the chipset is the L9963. Let's look at this chip in a little bit more detail now. The L9963 is the centerpiece of our BMU solution. It provides the key functions discussed and delivers differentiated performance in the areas that matter most, and that is ensuring the battery performs optimally and lasts a long time. Thanks for your attention. If you'd like more information, please visit st.com. I'm John Johnson for ST Microelectronics.